Ever wish you could just, tell your computer what to do and have it actually get you? Like, really understand what you mean.
Like it could actually read your mind.
Haha, almost. We're talking about natural language processing, or NLP. It's basically teaching machines to understand us humans.
Sounds ambitious.
It is, and we're diving into all of it today with this really detailed document on data science. It's from a GitHub repository, so you know it's legit.
The kiddo's got some great resources. Looking forward to seeing what's in this one.
Me too. It's amazing to think about how much data we create with language alone. Like on Twitter, people send out over 500 million tweets every single day.
500 million. Wow, that's a lot of tweets. But isn't that just, data? What's so special about it?
Well, you're right, it IS data. But here's the thing. To a computer, it's like trying to read a foreign language. They don't inherently understand what all that text means.
So it's like trying to bake a cake with a cookbook written in a language you can't read.
Exactly. All those tweets, texts, emails, they're basically a jumbled mess to a computer without NLP.
Okay, I'm starting to see the challenge. So NLP is the translator, helping computers decode human language.
You got it. It's about bridging that gap between humans and machines, enabling them to understand, interpret, and maybe even generate human language.
So instead of just ones and zeros, we're teaching computers sarcasm and emojis.
Pretty much. Think about it. It's already happening all around us. When Google predicts your search or filters out spam, that's NLP in action.
Oh, right. And what about those voice assistants? Siri, Alexa, they seem to be getting smarter every day.
Absolutely. Each interaction you have with them relies heavily on NLP to make that communication feel natural.
It's mind-blowing when you think about it. It's like, are we really talking to a machine here?
I know, right? So in a way, this conversation we're having right now, it could theoretically be with a computer.
Whoa, that's a bit freaky, but also incredibly cool.
Totally. But to really understand how it works, we need to dig a little deeper. When we talk about NLP tasks, think of them like different jobs or aspects of language processing.
Okay, that makes sense. So what kind of tasks are we talking about? What can these machines actually do with language? Think of it like, well, before you can actually start cooking, you need to prep all your ingredients, right?
Right, get everything chopped and measured out.
Exactly. So text preprocessing is basically like the prep work for NLP, getting the data ready to be processed.
So instead of chopping veggies, we're cleaning up messy text. Okay, I'm in. Tell me more.
All right, so imagine like trying to bake a cake, but you're using the eggshells and all. It's not going to turn out too well, right?
Definitely not a recipe for success.
Exactly. And it's the same with NLP models. They need that clean, organized data to actually work effectively.
Makes sense. So what are some of the steps involved in this whole data cleaning process?
Well, some of the key things you do are like converting all the text to lowercase. You also got to remove punctuation, and then there's things like HTML tags.
HTML tags, those are those things that format websites, right?
Yeah, exactly.
Yeah.
And they don't really add any meaning in this context, so it's all got to be stripped away.
It's like removing all the extra stuff we don't need.
What about emojis, though? Those are everywhere these days. How do you deal with those in NLP?
That's a really good point. Emojis can be tricky. I mean, we use them all the time to add emotion, but for machines, they can be hard to interpret. So during text pre-processing, they're often removed or replaced with like a standard representation, to make it easier.
So basically, you're standardizing those emojis so the machine isn't trying to decipher a million different smiley faces.
Exactly. It's all about making the data as clear and consistent as possible.
It's fascinating how something that adds so much to our digital conversations can actually complicate things for a machine. So once the text is all squeaky clean and prepped, what's next? How do we actually teach the machine to understand it?
That's where we bring in the big guns, the NLP libraries. They're basically these powerful software tools specifically designed to make working with language data a whole lot easier.
Ah, okay. So it's like having this whole toolkit specifically for language analysis.
So what are some of the go-to tools in this NLP toolkit? I'm ready to break out the power tools.
Well, two of the most widely used ones are NLTK, which stands for Natural Language Toolkit, and Spacey.
NLTK, I've definitely heard of that one. I think it's a pretty popular choice, right? What about Spacey? What's special about that one?
You're right. NLTK is a classic. It's like the foundational library that a lot of people start with.
So like the basic starter kit for NLP.
Yeah, you could say that. It's got all those essential tools for your, basic NLP tasks. Spacey, on the other hand, it's known for being super fast and efficient. It's used a lot in industry settings where performance is super important.
So if NLTK is like the trusty toolbox, Spacey is like what? A high-powered specialized set?
Yeah, that's a great way to put it. Spacey, it comes with these pre-built statistical models and a streamlined processing pipeline, which basically makes it super fast,
Yeah.
especially when you're dealing with, massive amounts of text data.
Statistical models. Okay, can you break that down a bit for me? What does that even mean in terms of language?
Sure. So basically, statistical models in NLP, they use like math, right? Calculations based on probability and linguistic patterns that they've observed in these huge data sets. And that's how they help machines make predictions about language.
So it's like teaching a computer to recognize patterns in how we use language, and then it can use those patterns to make like educated guesses about new text.
You got it. And that's really the key to how a lot of these NLP applications actually work.
That's really cool. So both of these tools, NLTK and Spacey, they each have their own strengths, I imagine.
Yeah, absolutely. NLTK is very flexible and customizable. You can really get in there and tweak things if you need to. But Spacey, it's more about speed and ease of use, especially for common NLP tasks.
So it's kind of like choosing between like different types of knives in the kitchen. You'd use a chef's knife for most things, but then you might need a paring knife for something that requires more precision.
That's a great analogy.
Hmm.
And speaking of specific NLP tasks, remember we were talking about named entity recognition, NER?
Oh, yeah. That was the one where you're identifying like key entities in the text, right? Like figuring out who's doing what and where. It seems super useful for things like, I don't know, summarizing news articles or maybe even analyzing social media posts.
Exactly. Think about being able to automatically tag news articles with relevant keywords, or even track brand mentions on social media in real time. NER can do that.
That's super powerful, though I can imagine it's not always easy teaching a machine to accurately pick out these entities from like a whole sea of text.
You're right, it's definitely not a walk in the park. One of the biggest challenges in NER is dealing with, the ambiguity of language.
Hmm.
Like, remember our Apple example. An NER system needs to be able to figure out if Apple is referring to the company or the fruit based on, the words around it and the overall context.
Context again. It's like those times when you read a text and totally misinterpret the tone because you're missing the context of the conversation.
Exactly. Machines face those same challenges when they're trying to understand us humans. Plus, there's always new entities popping up, new product names, companies, you name it. Keeping those NER models up to date with how fast language changes, it's a constant challenge for researchers.
It's like trying to hit a moving target. Language never sits still, does it? So how do researchers actually train these NER models to get better, to be more accurate over time?
That's a great question. One technique that's been a game changer for NER and a bunch of other NLP tasks is the use of engrams.
Engrams. Okay, I'm intrigued. What are those? Okay, engrams, engrams. So what are they? Break it down for me.
So imagine you're, like, trying to figure out what a sentence means, right?
Yeah.
But you can only see two words at a time.
Okay. Sounds tricky.
It is.
Yeah.
But you have to, piece together the meaning based on those word pairs. And that's kind of what engrams do. They analyze these sequences of words in a text.
Interesting. So instead of looking at each word individually, we're looking at these little groups of words.
Exactly.
Yeah.
Like a two-gram, which is sometimes called big-gram, that looks at pairs of consecutive words. So, like, artificial intelligence would be a two-gram.
Okay, makes sense. What about bigger groups of words?
Yeah, so you could have 3 grams, which would be 3 words, and so on. But the idea is, by analyzing these word sequences, we can start to pick up on those relationships between words,
Hmm.
and how they work together to create meaning.
So it's not just about the individual words themselves, but how they interact with each other, kind of like how those words fit into the bigger picture.
Exactly. And that's really important for things like language modeling, which is where we're trying to build systems that can actually, generate human-like text.
Okay, that makes sense. But how does this actually work in practice? Can you give me an example?
Yeah, so let's say you're building a chatbot,
Mhm.
right? By analyzing n-grams from, real conversations, you could actually train your chatbot to, understand the flow of a dialogue and how people naturally respond to each other.
Oh, I see. So instead of just spitting out random words, it can learn to sound more, I don't know, human, more natural.
Exactly. It's all about making those interactions feel more natural and less robotic.
That's really cool. It really highlights how complex language actually is. I mean, we just do it without even thinking, but there's so much going on beneath the surface.
There really is. It's fascinating.
It is, and this has been fascinating. From those early NLP tools to engrams, it's incredible to see how far this field has come.
It really is exciting, and it's only going to get more advanced from here.
I can't wait to see what the future holds for NLP. But for now, this has been an incredible deep dive, and I really appreciate you walking us through it all.
My pleasure. It's always fun to geek out about NLP.
And to everyone listening, thanks for joining us on this deep dive. We hope you learned something new and interesting today about the amazing world of NLP. Until next time.